MATLAB, and double-click this should allow it to install. This is the latest version. Sometimes double-click doesn't work, so I just right-click, I use repair, and I should have that. So this is a week 2. I posted some of the links in this Teams channel, and then if you click lecture 2, this is for the second week. And the first message I want you to do to know is we need to display the file extension because you are a programmer now, and you don't want to hide this file type. This file type with, for example, TXT or Word. They have different extensions, so you want to see them rather than to be hid by the different icon. Okay. If you don't know how to do it, just follow this instruction. If you finish that step, let me see, inside here, for example, I haven't done this, so this file, parsediff, for example, I don't know its extension. So the extension of this is .m, so M file. And inside, for example, in the resource here, I want to know the extension of those files. At this moment, on my computer, I haven't shown the extension of those files. Okay. What you have to do is go to this folder options and allow look at the view. Uncheck this. Okay. When you uncheck this, don't know if you can see. And now the extension of those files have been showed on here. So I know this is a GIF file, so I know how to do it, program. I know there's a TXT file and this MAT. Okay. So today, the first half of the lecture, I will lead you go through what we talked about during the lecture. It's about vectors, matrix multiplication, but that was on PowerPoint slide. But now we are using MATLAB and to do manually to code and create some matrix and do multiplication and use eigen function to find eigenvalues, for example, those. Then the second half of the lecture, we will go through cell ranger. I will show you how to get the cell ranger program and download and installed onto Linux server. Put some links here. And then we will look at how can you find example data sets from a 10x Genomics website and also from a geo database. or if you found a paper using geodatabase accession number and to download the data. And we will download either H5 file, and from or we have these 3 files like matrix file and those options. Some of those links require your registration. Some of the registration is easy, and so for 10x genomics, you can just register with your name, some basic information. Then you can download their example data sets and also software and all the information. And probably you can also use 10x Genomics Cloud in case you don't have a Linux access, because we do have a Linux server, so here on the campus, but you do have to register through this high performance computer center. So if you don't have an account on campus Linux server cluster, so we cannot finish today because you have to go through this registration, at least take 1 day. But I can show you if you have that and what you will do with this, okay? So now I'm going to open the MATLAB and also our PowerPoint slide and just go through those key points about vectors, matrix. Again, it's important to know the extension of all these files so you know what to do with them. And the getting started is a good resource for newcomers and you haven't used MATLAB a lot before. So if you don't have this layout, you can come back here and to see, okay, I want to use a default arrangement of this, then you come back to this interface with a command window in the middle, and then you have a current folder, and that's where your working folder is. And here the workspace is computer memory. At this moment, there's nothing, it's empty. No variable has been assigned, so you have a full space of a memory. And this is hard drive, okay? Hard drive and memory, the difference. What we did last week is to download and install Toolbox, so it's here. And also this parse, the Toolbox parse has already been added into, you see this parse has been added into this system's searching parse. So anything even is under this folder, you can still have access from outside. What that means is there's a function inside this folder called scga2, okay? Let me make font. So we don't have to be inside that folder to run that command because we already added the parse into the system. Okay, so even I'm outside here, I can remember you can use tab to complete and give you a suggestion of potential options. But if you only type C, is not enough. There are too many functions you can choose from. But if you see SC, single cell, gene express, then tab, you only have those options. And when you want to upgrade the program, you will come back to the same working folder here, and then just run those commands again. You should be able to overwrite everything under this folder. It doesn't matter because you can overwrite it again and again. But you don't want to be inside here and then download, overwrite that again, because that will put the new version inside here, and then you create some layers inside.
How did we reach here? Because I'm not able to find that folder for myself.
Yeah, so if you don't have that, I'll show you where. Yeah.
So it doesn't add to the account that we downloaded last time.
Yeah, the team has the instruction. So if you don't have that, that means you haven't installed it. Yeah, so if you haven't installed it, just a Google SLG toolbox. You should have this quick installation. Yeah.
Oh, so every time we should do it?
No, after you download, you don't need to download.
I should have this. Last time I didn't.
But I don't know why. I still need to download.
Mm-hmm. So if you don't have that, so you just copy those code. Basically, this source code is just go to this website, download the zip file, unzip it, put it there, and add that to the parse. That's all. So, but you just don't want to do put it in the right directory. Okay, that's your working directory. You only have one copy of those.
Because she said last time she installed MATLAB in her computer.
But it's gone.
Yeah, last time I downloaded the
Same computer.
this, but it did not stay. I think it's doing.
Oh, maybe last time it's you. This time I log in.
But it should stay in this.
The MATLAB itself should be there. You just share the same MATLAB, but I don't know this package. It's
You only install everything.
Oh, it's only the package that is not there, and the MATLAB is not opened yet for her.
Oh.
It's because of
You have to use the same computer.
Same computer and same log username.
Oh,
Maybe. But that doesn't make sense.
No, because you log in your net ID and the computer will remember it, but you need to use the same
yeah, it's
computer.
like I downloaded the same thing last time on my account, so.
So maybe if I use it, I cannot use it. I have to
No,
download it again.
you're downloading again.
Mhm.
That doesn't make sense.
Even I don't know.
The same computer.
Yeah, it was here, so I did not use this to use this. It was this one.
Yeah, so even for this, if I run that program again, if at my end, if I update the package, you will get this message. Say, okay, the version here is not updated because I work over the weekend. Sometimes I change some source code, and you immediately get this message. If you don't want to do the upgrade, then you just skip the updates. Okay, most of the time it should be fine because it's just very small updates. For some of the function, maybe you have never used it. But if you want to do the upgrade, you just click yes. You will be led to that page and copy this again, and then come back. Make sure not this page, just go back to this folder, working folder, and paste those. You want to be in the working folder and to overwrite this subfolder here, not inside the subfolder. Then you create another subfolder. We try to avoid that.
So that means make sure the current folder is your main folder.
Yeah, the folder, not inside the main folder.
The main.
Yeah. Or you can delete the whole folder and then just run that again. Okay. So if I finish this, if I run that again, I shouldn't have that still. Just skip this, okay? Then you shouldn't have that message. Okay, so vectors. I showed you last time we can type that in. So if you want to define a vector, so this A is our data point. So this is a vector defined by 12.3, 4.5, 6.7, and 8.9. And then just use this squared bracket to finish it. So I skipped the comma here. You can add that in, or you can use the space, it's fine. This will define a row vector. So this is a 1 by 4. You want to transpose it because we always think this should be the correct way to show a data point. So A is one of the data point. So you put this apostrophe around it. This will transpose the vector. So now you have a 4 by 1 vector A. If you do that again, you transpose back, and if you do that again, you come back, okay? Or you can use transpose the function name. Should be this. Do the same thing, okay? So this operator is a shortcut. So you don't have to write a function to do it, but it's doing the same operation. So now we can put a B. If you want to type column vector, say 2, and then if you put a semicolon here, then it will start to give you some kind of return, and then you construct a column vector directly here. So make sure it's different from a comma, but it is a semicolon. And then 3, 1, 5, something like this. This will automatically create a column vector, okay? So now we have A is a column vector with 4 numbers, and B is a column vector with 4 numbers. Can we do multiplication A times B?
I can't remember if the order is rows and then columns or columns and rows when you're expressing.
Yes, so it's in my case here, A is so is 4 by 1. Yeah, row first. This is 4 by 1. B is 4 by 1. So can we do multiplication A times B? 4 by 1. 4 by 4.
Or 1 by 4.
Mm-hmm.
4 by 1.
We cannot do this multiplication because if you think about this matrix multiplication rule, you have to this inner, the dimension has to be the same. So that's why if you do A times B, you should give this so-called incorrect dimensions of the matrix multiplication. Okay? But if you haven't learned this at all, you probably want to say, okay, I have 4 numbers and I have 4 another numbers. We should be able to, you can do A plus B, right? That should be easy. So now if you put A and B side by side, you see this, you make a combined, so you make a C matrix. Yeah, just play with those operations. Gradually, you know, okay, what to do with this. Okay, so you can do A plus B. You cannot do A times B directly, but you can do A, put a dot, times B. So this dot indicate the multiplication will be element by element. So you have 4 numbers here, 4 numbers here, you should be able to multiplicate by. Okay. So if you want to do element-based multiplication, this is the route, the way to go. Otherwise, MATLAB will consider the multiplication is matrix by matrix, that you have to follow the matrix by matrix multiplication rule. But here is element by element, okay? Now what I can do is to transpose B first. So A is 4 by 1 and B is 4 by 1, but now I transpose B and the B becomes 1 by 4. In this case, my inner dimension matched, so I have a vector 4 by 1 times a vector 1 by 4, so I should be able to do it. The result of this will be a single number here. So let's see, 4 by 1, 1 by 4. So the result should be 4 by 4. Okay, so that's what you see on the screen. So we gave a name in the lecture. This is called outer product, right? A and B. 2 vectors. I don't know if their function called outer. No, we don't have. Cross, maybe. It's not. So we don't have a function to do this outer product. Let me do a search. So in MATLAB, there's no built-in outer product function. You have to write your own if you want to do it. okay? But that's the way you do it. So now if you do transpose A times B, okay, that will be so-called inner product because you have vector 4 by 1, and you transpose it become 1 by 4, and this side 4 by 1. So at the end you get a single number. Okay. Mm-hmm. Yeah, you get a scalar at the end. So now I want to take a sum of A. So the A, if I do, this will put everything together to give you the total, okay, this function. Now what you can do is to A element divided by sum A. So this will give you a normalized version, okay, A norm. A fraction of A element, okay? So I do this. So look, A was like this, 12.3, 4.5, so I made it up. Then if you do this operation and you get how much the proportion of the first element compared to the total, and this, okay, so you get the fraction values. And 37% the first element, okay? So this is a normalized fraction, and then if you do sum for this fraction, and then it should be get 1 because this total is 100%. Okay, so to give you some flavor of this, how you use command line to do those things. This FA underscore A, you can use this. Yeah, explain that again. So you have a vector, have 4 numbers. You want to know how much the first element occupied the total. Now, after computation, I know this is like 37%, the first element. That's what I did. Is to.
That function tells us the percentage?
Yeah, it's a kind of, you use each element, each element, remember this is dot product operation is take every element divided by a same number. This number is total, so that's a percentage, basically. Yeah, the fraction of each element in total. So this F underscore A will be very useful if you multiplicate this with B, okay? And you get a single number. And you can consider this fraction A is like how you take proportionally from a B each element, and then sum together. So it's kind of a weight, okay? So the first element weight, 37%, second weight, 13%, 14%, 20%. So you take 37%, the first element from a B, and 14% from B, second element. At the end, you put everything together. So this operation gave you a way that you take different proportion and from the B vector and put together, and so gave you this just like you're cooking and you do how much salt, how much pepper, and those things. Yeah.
I sent the request to join.
Yeah, I should receive it from. I will accept, then you should have access.
Thank you.
Yeah.
The last one that we did just now,
Yes.
the last function that we tried just now, like fraction
Yeah.
of A transpose with product of A transpose and B.
A transpose.
Yeah, the last one. So
This one here.
Yeah.
Mm-hmm.
So in this, is it like we did the A transpose B product before? So that product is divided by.
This product.
We
This
did
this is like a normalized vector. So the normalized by the element in A and by the value.
And then we multiply each of that with B,
Mm-hmm.
and we get a scalar quantity.
That's right. Yeah. So this is A. Okay. This should F A, and this is a B. So this is two vector. You are doing this multiplication. So I think what we did is just this times 2 and plus this times 3 and this times 1 and then this times 1 and put together. Yeah. Yes.
When we define A and B, how can we distinguish whether it is a column or a row?
There's no, yeah, so if you do size, so A, and you will get the information about the first number is the dimension of rows and the second is column. So in this case, we know A is a 4 by 1. Okay. So all those are the very basic addition, subtraction that you can use. You can plug in some numbers to play with it. I think the next is we are trying to have a norm, okay?
I'm sorry, could you repeat? You said the first number when you
Yeah.
Okay. Sorry, I just
Mm-hmm. What you can do, for example, you can assign this into two new variables. So xa, ya. So you get two numbers. These two new numbers, each corresponds to the dimension number of this. So you use those technique to do the program. So you link one command with another and make new variables. Yeah, but for now, you just know, okay, you can get the information out. Now you try the norm of the vector. There's a function. So for A, if you do the norm, is 17.1942. So what's the meaning of the norm? Norm is the length of this vector. Okay. In our case, this vector is in four-dimensional space, so you cannot see it, how long it is. But you imagine if you have three numbers, you should be able to know x, y, z vector, so you know it's here. So from this point to the origin, so this is how long it is. Yeah.
After you transpose vector, how can you go back?
You just transpose it again.
Okay. Oh.
Yeah, you transpose. Yeah. So go back. So the norm will take it. It doesn't matter it's 1/4, 4/1. It's always the same because at the end, the length of this vector is a single number. Okay, so that's why if you transpose it, this vector, you still get the same ID norm.
Can you please scroll down? I want to see.
Go the.
Can you scroll up, please?
Oh, scroll up a little bit. So A has values of those. So if you think of this dimension, and if you have a 3D, it's easy. X, Y, Z. Then my first number, 12.3, will go 12.3 somewhere, and then Y, and then move 4.5 here, and then move up. So the first three dimension move my vector to here, and then I have to find the fourth dimension somewhere, okay? And then I found this point here, and the norm will compute the distance from here back to the origin. How long this is a norm A. So this is A, and the size of this will be norm. This is a norm. Okay? So now I will replace, for example, make this number smaller in A. My norm should be shorter. Okay? So that's what I'm going to do. So I extract the first element from the A, right? So this is, we know it's this. I can replace this to a small number, 1.2. Okay? Now, my A changed. It was 12.3 something, and now I replace the first element, use a new number. So now that my norm will be smaller. So what was it before? It's 20. Yeah, it was 17, and now it's 12. Okay. Okay, unique circle. So how can I know if I have a 2D point, two numbers of vector? How can I know whether this point is on this unit circle or not? For instance, if you have a x, this number is 0, 1, okay? 0, 1, 0, 1 is here, so it's on this unit circle. And 1, 0 also on the unit circle, of course, okay? But how about the 1, 1? Is 1, 1 on the unit circle? 1, 1 is not, because the norm of 1, 1 is not 1. So in order to be on the unit circle, you have to have a norm equals 1. Okay. It should be square 2. It should be this, and then the norm of x should be 1. Okay, you have to be, in order to be there, you have to satisfy these two numbers. Once they squared and the sum together, it should have to be 1 and square root be 1. So that's why you can decide whether this point is on the unit circle or not. Just take this norm, see whether it's equal to 1. It's easy to do because if you have a sine cosine function, so you have a cosine 2.5, 2.5. So this should be the norm should be 1, because those function by definition is by definition this cosine and sine will definitely guarantee you are rotating on this unit circle. Okay. We know how to do this. We know how to, for the identity matrix, there's a built-in function called I. Okay, if you do 5, it will give you a squared matrix, 5 by 5 with diagonal or equals 1. Why we need those kind of function? Because this matrix, if you multiplicate this by a vector, will not change any value of vector. So it's somehow to help you to link with some dimension, okay, without change any values. Easy. So maybe you want to type the matrix A and the type of matrix B in your computer, see whether you know how to do it, and then do this multiplication and to confirm this is correct. Okay? So I'm going to type that in and just, you don't have to do many times, just once, you should be able to know. So now I have A is big matrix, then I have a 4, 5, 3, semicolon, 3. So I have my A. I put a semicolon at the end so I don't print out on the screen because sometimes the huge matrix will take some time to display. B by rows.
Is it all right to not put commas in between 24400?
You can put, you can ignore, yeah, you can skip as long as you give the space. Mm-hmm. Okay, so just okay, why we are doing this? I want you to know this matrix multiplication vectors was a basic concept, not only on the mathematical formulas, but also if you have that formula, capital A, you know, okay, you can type that in, you can play with using these command lines. And there are practical reasons, and later we probably will play with this expression matrix. We want to extract some of the genes expression, and maybe we want to combine some program of some gene sets in a different proportion, and then to see which summation of those and reflect in the real observed single cell data. So there are some reasons that later you want to use those. Okay. For example, by now you should be able to know. You should know if you have a matrix like gene expression of these 2 genes and 6 cells, you should be able to extract number 9 out. So gene number 2 in cell number 4, what's that expression of that particular gene? Do you know how to do it? So if I assign this into C, just consider C is our expression matrix. Then in order to get the second gene expression in number 4 cell, then this value I can extract is 9, okay? So how can I extract both genes expression in cell number 4? Let's use this colon, and then you get 2 numbers, okay? So this gives you the information of the cell number 4, gene 1 expression level is 15, and the gene number 2 expression level is 9. So you can do this. Other language has a similar syntax. Julia, R, Python should very similar. So this part, like to do this indexing, should be computer language agnostic. So you don't. If you know this, basically other languages are the same. You can get the total first row of all the genes in all the cells by extract the top rows. You can get 2 genes is from number 6 cell and number 2 cell. So you can do this extraction by the index, and also those indexes start from 1, and some languages start from 0. the whole, yeah, from, so you don't care the values. You can jump, for example, from a cell number 1 to 3. Okay, so those are the very basic indexing to extract information from a matrix. So you should be able to get those tutorial to teach you how to do this using the getting started, those links. Again, no matter which computer language, this is very basic. You should know a little bit of those. If I jump, say 1, jump 2 to 6, so this will do the 1, 3, 5 for me. So the 2 means the step. So you start from 1 and jump 2 steps. So 1, 3, 5 until you reach the end of this vector. If you do 7, it's already out of the boundary. You should have an error message because the matrix is 2 by 6. So if you jump out of it, it doesn't work.
I'm slightly confused. So when we did the multi-step jumping just now,
Mm-hmm.
so
So if you do 1, 2, step 2, and column 7, this will create a vector. So it create index 1, 3, 5, 7. So you don't have to write yourself. Yeah, this is create a series of numbers too.
okay, it's not from the matrix that we have, right? Is it creating from there?
Yeah, it's generated by itself to give you an index. Then you use as index to extract the information from the matrix. Mm-hmm.
Extract in the 1, 2, and 7.
No, if you write in this way, 1, 2, and 7.
Then that would be 1 to 7.
Yeah, so in this case it's 6 because we only have 6. But if you write in this way, it create a series number, so by this indexing.
So it means that we take from 1, but we have to jump the 2 steps.
Mm-hmm. If you jump 1 step, then you can write this way. So you jump 1 step each time, or without even ignore it. Yeah.
Gap it means to have between us.
Yeah. If you don't have this, it by default just jump 1 step. Okay. You create this index very easily. Okay. Now you can play with this. Let's clean this space. Now you have a lot of stuff in your working memory, and you may forget that the x is something. So you may. So we want to clear it. So you can do clear all. This, if you want to clear just one variable, you can do clear a. So the a will be gone from the memory, but it just clear. Then your space is clean, and then CLC will clean the screen. Okay. You still have access to the history of your comments. So if you want to use need that information. What you typed before is still there. But this layout by default will not have that. So now your job is to define capital A here, and then define first x as 1, 1, and you do the multiplication and see the results, and think about capital A, this squared matrix, as operator, and then you try another data point, 1, 2, and do this multiplication. Okay, so in my case, I gave variable name as a v. You can try this. Okay. The concept here is don't consider A as a collection of data points. It's not a data point anymore. It's not a data. It's operation. It's operator. Okay? You treat this squared matrix as some operator to apply to change other data points. Okay? This is the idea. Okay, so now I'm going to define this what is this? 1, 2, 2, 4. Is that the one? All right. So if I apply this multiplication A with a number, so let's see, this will be 1, 1. I change this number to 3, 6. I apply this to 1.2, 2.3. I change this data point to 5.8, 11.6. Okay, so you on this space you have infinite number of these points. When you apply A, they start to rotate around. There are some rules you can follow. The rule we know is if you apply this to 1, 2, and 1, 2 become 5, 10, and there's no rotation in terms of this origin of this xy axis. I don't know about the 2, 4. Is 2, 4 also should be? Okay, basically on this particular line of the numbers, once you apply this A as a matrix, multiplication operate, no change of the no rotation, just change the length. Oh, by the way, you can apply A to multiple. You can apply this to A1. Okay, so the matrix here is a collection of 2 data points, right? We have 1, 1. Remember, it's a column wide. We have 1, 1, 1, 2, 2 data points. It's just put together. I can apply the same operation, A, instead of individually to these 2 data points. I can apply to the collection of these 2 data points as a matrix. So this multiplication of matrix. The results will be after this operation where the new data point should be after rotation, stretching. You can have more if you have a 3, 4, 5, 6. It doesn't matter, and you just do the operation. Maybe I should transpose it. Three, 5, 6. So I add 2 more data points, and I can do this operation on them all at the same time, okay? And then to know to find out those special points, which when you apply A, there's no change in their angle, no rotation. So you can use the function applied to this squared matrix to find the data point, the vector. Okay. So this vector is column based. So the number is 0.4472, 0.9844. This is not a 1, 2, but the reason has been normalized and put on this unit circle. So 1, 2 is here, but if you drag it back to the unit circle, it should be this number, okay? And the eigenvalue is 5, because when you apply A to this number, it will increase the magnitude, the norm, by 5 times, okay? I think we can take a 5 minutes break, and this should not be so easy to digest, but play with some data, and we gradually get there, okay? Up a little bit. Mm-hmm. So in the class we mentioned, once your sample has been processed, a sequence, you will get FASTQ files. And normally, if we do this in our genome center here, their service will send me a PDF. This not PDF, the FTP link, okay, where I can download this large zipped sequence read files. And for each sample, you should have two, and your collaborator or you should know what that means for each. For example, you have two samples, then you should have 4 files. Okay, come back. So I'm going to show you, once you have those files download, for example, you don't necessarily have to download on your local machine as long as you have a link. And how can you use Cell Ranger in order to get expression matrix? And also the name of the genes, and also the barcode of the cells. So that's XGC or XGB barcode number is what we really want to get out from this step. So this step involved in the process those cells, raise and map to the reference genome, and the expression level coding, and construct this matrix for you. Okay, so there are 2 options. If you know how to use Linux, so this is a computer on the campus, high performance computer cluster, then you can install Cell Ranger on this cluster and save these files into the cluster and to run the program and download output file and to your local computer start to downstream using our tool or whatever tool you want to use. Another option is to upload those files to 10x Genomics cloud service. So this cloud service server, 10x Genomics, so this website is here. It's provided by this company because they know not everyone has access to this powerful Linux server. It requires command line skills to do this correctly. So they provide this web-based cloud service. So you upload your files and select the reference genome. It will run Cell Ranger at the back end and send you the output file prepared to you. It's free, yeah. It's free, and you have to register and you have to spend time to upload this to the server. Sometimes if you have a lot of these large files, take days to upload, but once you upload there, all you have to do is select R1, R2 file and call the name and wait. And then R1, R2 file for another sample. Just organize the files correctly, and then you should get the results. Okay? I don't know whoever has this. Anyone has this account? It's free, but you have to register. But let me see if I can use my examples to show you what looks like inside there. So I have account from one of our collaborators, so I'm going to use his account to allow you to peer inside what this service provided. So for each of this, you create your own project. So in this case, there are several projects. So let me select just one. Okay, so this has been put there for sometimes several months, so it's so-called expired, but it's not. So you see, for this experiment, this is one sample, okay? And then we upload 2 files. Then the cell ranger will run, and it's only take like 3 hours to finish this. And you get a page like this. There's some settings and which version, what's the reference, what's the chemical about this experiment. This is the mouse, okay. You want to check this result summary. This is a page here, okay. This experiment, there's only 1,400 cells have been called out, and the curve doesn't look very good. There's no clear difference between contamination and the cells with droplet with cells. You expect to have a plateau and then suddenly have a drop, and then you have a clear cut. You know, okay, those are the cell droplet with cells, those are the empty cells. But here you have a gradually declining curve. This is not good because there's a lot of gray zone. You don't know where to cut to put the cutoff. At the end, this is not a very successful experiment anyway. And from here, and you have output files. And as I said, this HDF5 file is what we need, okay? The program produced 2 versions. One is before the filter. This row, in this case, the cutoff is very relaxed, so you have a lot of cells, but maybe 20% or 30% are not real, but just for case, for the safety, the raw data is still generated, but using a correct cutoff, you should have the filtered version of this, and the file is much smaller here, and then you can download this H5 file, and then you should be able to read that into MATLAB. Okay, so this HDF5 file is preferred format at this moment. But the previous version of the cell ranger will generate 3 files. One contains the matrix, another is the cell, another barcode. So you have to zip them and unzip it. But now they found the better way, which is just one file and contain everything, and H5 file is a scientific data exchange standard now, and the people use that a lot. So they found this way is more efficient. So you just transfer one file and contain everything. But you still have option if you have older version of the cell ranger generated those 3 files, and we can still read it. Especially those uploaded to the GEO database, they still have a lot in that format, so you need to know. Any questions for this part? So I'm going to jump into Linux server and to show you those. So I always ask my collaborators to do this by themselves, because this is just drag your file, upload, and click. If you give me this, I have to spend 2 or 3 days to upload to do this. But I wish I only get those output file and then this file directly to do the analysis. Okay, this is here. Now let's see if you want to download another link. This is where you can download the cell ranger. I probably need registration. So this is a 10x Genomics download center, and the most important program certainly is the cell ranger. Here they provide, now this is 7.2, the latest version, and they also have other, this loop browser. But let's see, you need to check your system requirement. Okay. Binary Linux. And then here you can download this zipped file in your local computer, or use this to get from the link. Okay, you copy this, and then you have to know how to unzip it. Okay. Basically, you download that into your Linux server, unzip it. That's all. All right. So I'm not going to. I'm going to do it here. So that's my Linux server. There are several servers on the campus. The Grace is one of this. I can have access to the command line for this server. So to use this, you need another training course if you have never done any Linux command line. Okay, I have that. So under my account, I already downloaded the cell ranger, and it has been unzipped and put here. Yeah.
When I tried to unzip, it said that my disk quota was exceeded.
You mean on this server? Okay. Yeah, that's another problem. So you have to discuss with the high performance computer center and let them to give you more code.
Okay.
Yeah.
If they do it in the scratch directly, we have VLS quota. If they do it in normal, when we switch to the scratch directory, you will have 1 terabyte of disk quota.
Okay.
Yeah, I can upgrade, for example, to this latest version. So what I can do is just copy this comment. I copied the whole line over here. It just gave you where to download this program, and then you can just paste here and then just run this. Yeah. I don't think so. You need to have your cluster account. Mm-hmm. If you don't have that, it's okay. Just look at what I'm doing here. Yeah. So I just download that file, and then I can do unzip and cell render 7.2. Zero. Now the program just unzipped, and you should have this tar file, and I have to how to extract this. So after unzip it, I should have a new folder, and the new latest version should be in there. On the other hand, you have to download the reference genome. So here you have so-called reference. You have to know as a human and which version you want, and basically do the same thing. It will download the human genome transcriptome information and put in the, another folder, and it's already formatted. Yeah.
But what's the benefit to run cell ranger by yourself if it's free and
Mm-hmm.
why somebody else can run it for you? Why do you?
Yeah, there's no benefit. I think for the individual labs, you only have a couple of samples, then you just upload it to the cloud and get the matrix. So this command line and is for if you do this a lot of times, faster should be, yeah. You don't have to upload to their server, or you want to keep your data set secret, something like that. Yeah, so again, because this cloud service is available, so all I'm doing here can be replaced by 10x Genomics Cloud service, okay?
You said all that you're doing here can what? You can do it on.
You can do it online, use this 10x Genomics Cloud. Uh-huh. So now I have this new version, Cell Ranger, installed. I can remove old one. I don't have to. 7.2. So now I can switch into this folder, and then see here, I have a program called the Cell Ranger, okay? That's where you type your command line here, and I didn't give any arguments here, so there's no function, but you can read the documentation and see I'm going to do the count, their construction of the command line here, okay? Any questions for this part? Okay, now, yeah.
For people that don't have an HBRC account, should they just sign up for one, or what was the go around for that to use the?
Yeah, you should sign up for one, and it takes some time to you get it. Yeah. But if you don't want to bother and just use this should be okay for most of the case. Oh, there's one scenario that you have to have a Linux. If you're working on not a human and a mouse, but another species, that we have from a sheep, from a zebrafish, we need to construct our own reference that require Linux, that require Cell Ranger to run. Then you build your reference, you can upload your reference to here. Yeah, there's command line, use Cell Ranger to make reference.
So they only have human and mouse?
Yeah, I think so, yeah.
Will we work on that?
Yeah, so if you see the Cell Ranger here command, including this make reference. So in this case, you need to have, for example, sheep, FASTA, that's a genome sequence, and the GTF, that's an annotation of their genes.
So we need to have someone who has already, like, sequence from someone who has already done.
Yeah. If it's a species, there's no reference genome at all, it's completely unknown for its genomics. We just cannot. Cave fish will be difficult.
Yeah,
Mhm.
so, yeah, because we just received data,
Mm-hmm.
so I thought if I can upload that, then we
Mhm.
have data.
Yeah, so if you have those, like in biology people and in ecology, completely unknown species, then you should have some draft genome. Yeah, you sequence a little bit and put a draft genome in context. Yeah, you can have your own annotation. So if you have that, you should have FASTA files and the GTF files. You should be able to.
That's why they are annotated.
Mm-hmm. Yeah,
Because we don't have annotations.
yeah. This is fundamental research. Yes.
Will we learn in this class how to annotate?
That's another class. It's called evolutionary bioinformatics. I taught that several years ago.
You have that file installed, saved in your computer, and then input that file into the Linux,
Yes.
the server.
Yeah.
To use that
To make a reference, you have to use Cell Ranger on the Linux here. You cannot do this in cloud. Yeah. But for human mouse, it's okay. Now I think we can move forward. So let's assume we have this. Okay, we are going to visit example dataset in 10S Genomics website. So that's the one, and they provide quite a lot example dataset, and linked to different products they provide. They have certainly single-cell RNA-seq and also different version, and also spatial transcriptome, single-cell attack-seq. So the first thing you need to select single-cell expression analysis, right? their genome sequence as well, the single cell CNVs. Then after you check this filter and all this 197 data sets is from single cell gene expression. And most recently, you have a single cell gene expression flex. This is a very different setup. But now we just select this. And from this side, you see, okay, this 197 data set, they're from either human or mouse, and use different versions of chemicals. 3.1 is recent and called by different version of cell ranger. And also their tissue and cell type information available. Yeah, just click the first one, and as an example, this is a 5K human PBMC 3-parameter again. This is a good resource because they put high quality data and as a demonstration. So I just visited the first. This page looks almost the same in the output you get from the 10x Genomics Cloud service. You can view the summary, this page for this sample, and 5,000 cells. And look, this beautiful, this curve is better than the one we just saw. Okay, so some very quick check of the quality. And then come back to here, you see this original FASTQ here, 15 gigabytes data zipped. And then come down here and you can see this so-called cell matrix HD F5 file is with what we need filtered, okay? So if you want to download that 3 files format, it's still available as a zipped folder, and then you unzip it, you will see 3 files in there. But what we can try is to download this by click. Okay, so now this example data now is in my download folder because I see the extension is H5, so otherwise you don't see it. Okay, I remember it's in the download folder. The name is this. Now I can come back to MATLAB. We start to read that data in. You select this 10x Genomics H5 file. Okay. I just click, and I know it's in the download folder, so I select this. Again, it should work. I don't know. Sometimes the program crash. Okay, so in this case, we can easily read that in this 5,000 cells. Okay, I hope you can get this step easily, and you can try other data sets, not a PBMC, but anything, this 197. So I will work around and see whether you, which file you download. Yeah. Yeah. In your download folder, I don't know. How about yeah? So document. I don't know where the.
I didn't know. We can use the example file also.
Example file, yeah, should be okay. The same. Oh, I realize you probably have a problem to download, and you don't know where the saved to.
No, actually it said we needed to make accounts.
Oh, so because of the network problem here, there are restrictions.
Is there any, we can download the 10x genomic file from here?
Not directly. You have to download first, and then you load here.
Okay, yeah, that's
Yeah.
what it's taking us.
And you still need to find where you save. Is this here
I
inside?
did not download actually. because
Okay,
it
okay,
asked
yeah.
me
You know what I can do? I can provide this file in Teams. Then you download from Teams, save to it. Okay. So I will upload this file to and now this file is in the Teams, and in this team in lecture 2 here, and you should be able to download this file to save in the folder. You know where it is. Then we should have this 5,000 cells in the system. So most of the time you will get confused, so which button I should click first. So that's why I provide this particular guidance here. If you click this corner here and you start to see the 1, 2, 3, 4, 5, basically the 5 buttons will be, you click from 1 and then 2, 3, 4, 5, you should get the analysis done. And then the first button, if I know what to click, I don't need it, okay? But for now, I just click the first one. I see, okay, the first one is the same as this. It's a filter, and try to look at the cell, look at the gene, and do some quality control. And if you have a gene almost no expression across all the cells, we don't have to take that into account. We will remove it. So this gave you the filter of gene and the cells, and then so this tells you the first button you should click is this one. So now I just click it, and then select this basic QC. We will discuss about QC next lecture and see what are those, and I will using very stringent, like all these parameters to set a cutoffs. And then if a cell good enough, I will keep it, otherwise discard it. The gene has to be good enough, so I delete quite a lot of genes, okay? Now my original matrix was 13,000 something, okay, 5,000. But now I removed a lot of genes and cells and make this matrix smaller, but still contain enough information for next step. Any questions? So now you can click button number 2 and click, okay, see, okay, this number allow, this next step, you should do this so-called embedding, okay? You found, basically you will rearrange the cell by their similarity and be ready to cluster them into different clusters. So that's the button you want to click. The second button should be this one here. You can either. Now you can select several methods, and when you see a turtle, that means very slow program. So you will try to avoid those. And Tiffany by default will be number 1 selection, and then you just click OK. If you don't know which button to click, and just use it by default, you should have the one that, for example, here, and by default, the 2000 highly variable gene will be selected, so you just keep going. And this is step 2, okay? So once you're ready, then click button 3 and see what the next. Okay, remember you have a tool here, small toolkits, and then, for example, this, if you highlight, you can start to rotate the 3D. You can drag, you can zoom in, zoom out, and you can select cells, okay, by brush it. Okay. Then you can restore the view. Remember, you can have these operations here. So now, step 3, you click this. Okay, so that's what we are going to do, the cluster cells into groups. So you click this button, it's here, or either click this or this. And using this embedding, yes. And I will cluster based on this embedding. And I will use this rabbit is good, okay, it's fast. Into, by default, 50 small clusters. So the strategy here is to over-cluster cells into many, many small clusters. I just guarantee each cluster has like 50 or 60 cells to enough to let me to determine the cell type. So later, once I have a similar cell type of 2 clusters, I will merge them into a huge cluster. So this is try to avoid those issues with number of cluster selection. So we don't select how many clusters, we just cluster them into many small clusters, and we merge them later. So after you finish this, you see, okay, there are many small clusters. Number 4 steps will be give the cell type, okay? So it's this button here, and I will click this, and then select this mouse data, and we'll see automatically assign the best guess of each cell type. So the program start to go through all the clusters and search the database and assign the most likely cell type to that particular cluster. Because we have 50 clusters, this program will run 50 times and assign each of the clusters by their cell type and give you this subscription about the cluster ID. At the end, if you have a multiple cells, but multiple clusters share the same cell type, like NK cells, it will ask whether you want to merge them into one. Normally it's okay, unless you want to study subclusters of the fibroblasts. You have 15 different subclusters, you want to keep them. Otherwise, you finish the number 4 analysis here. Okay. You should merge them most of the time. So last step. Okay, you can save your data. Now you are ready. You need to save your data. So here, if you only work at this session and you keep temporary output this into workspace, it's okay. You save the matrix, gene, the objects, so it's here. Otherwise, you want to keep as a file, you can save this into MAT file. And then I will just give a name here, test, okay? And save. So remember where you save your file, and here I just save it in this working folder. And now if you shut down this, you should be able to come back to this page. Okay, so that's all for today's lecture. Most of the time, I just click this button to make a video and to share with collaborators, so they know what the cell type in their data, how many, and whether the calling of cell type consistent with their expectation. Okay, any questions? No? Well, okay.